Hello, Miss Welsh here. Okay, so we are going to do question 1 from day 5 with geometry, and you can see that this is a paper 2 from May 21, and it's question 5. And there's always 5 questions on paper 2, which means that this is the last question of the exam. Dum dum dum. All right. Hollow chocolate box manufactured in the form of a right prism. Remember what a prism is? It means that the cross section, which is the base, it stays the same throughout. Yeah. So the top and the bottom are the same. So a pyramid is not a prism. Okay, with a regular hexagonal base. The height of the prism is h, and the top and the base have sides of length. Okay, given that sine of 60 is root 3 over 2, show that the area is this of the base. Oh boy. Okay, I'm going to erase this. Okay, so they're telling us that the sine of 60 is root 3 over 2. Remember these paper 2 questions? They're like a story. So you're expected to use the previous information into the next section and all of this kind of stuff. So we're going to have to use this. But first, let us start with a hexagon. And, well, what are we going to do? We are going to divide it into 6 sides, and all of this would have been 360s. 360 divided by 6 is 60. So each one of this is 60. And in fact, if you then do 180 minus 60 divided by 2 to find these two sides, because the radii, or no, these sides would be the same, you actually then also end up with this being 60, okay? So you end up dividing a regular hexagon. Regular means that all of the sides are the same, into equilateral triangles. That's good news because that means that equilateral, all of them are the same, all the sides, which means that all of this is x. So how do we start? Remember, you have to keep your wits about you with these questions, meaning you really have to be ready to use the different sections of the syllabus. And here, perhaps you remember that the area of a non-right angled triangle, you have a formula in your formula booklet, is AB sine C, okay? Where A and B are they're the sides that constrain the triangle, the angle, okay? So then we can substitute this in contained angle. That's the word I was looking for. It's late. Okay, so x times x, and then you have here, you have sine 60. And now, remember, story, woo, your alarm bells are going off. There's the sine 60. Please do not type it into the calculator. You will be way off, right? Root 3, you're going to get into messy numbers, and then, well, then you're dead. Sorry, it's true though. All right, okay. Yep, and there it is. Woohoo, look at that. So then here we have root 3 over 4x squared. Oh yeah, not yet. Yeah, not quite yet. So what this is this is one equilateral triangle. Remember, we have a hexagon, okay? So therefore, remember what the hexagon is. I'm artistically challenged. Okay, remember what the hexagon is made up of. It's made up of 6 of these babies. So what we're going to do is we're going to take one of them and we are going to multiply it by the area of one triangle. You can see you already have the root 3. You can see you have the x squared. And so now you remember that 6 over 4, if you divide top by 2, bottom by 2, there it is. Whoomp, there it is. Whoomp, there it is. We did it. We showed that this is the area of the base. Fantastico. Let's keep moving. Now it's going to be the toughest part. You can see that it's worth 5 marks. Given that the total external surface area is this, show that the volume will end up being this. All right. So remember, with these optimization problems, they give you like a friend, they give you like a constrained equation, right? So some information. And so that's what they're doing with the external area, okay? Well, our total surface area is going to be, well, you have the top and the bottom. So first of all, they gave us the area of the base, right? So we are going to do 3 root 3. And again, like, feel free to pause this and try it on your own at any point of the question. It's so healthy. I'm going to multiply it by 2, right? Because we've got the top and we've got the bottom. And look at this right away. The 2's cancel out. Don't be afraid of that. And then you have these 6 lateral sides, okay? So this is just a rectangle, and so this is going to be x times h, and then I'm just going to put 1, 2, 3, 4, 5, 6 in front of it, okay? Now you know they told us that this is 1200, and so now you have the expression of 1200 3 root 3x squared plus h. All right, so if you've done these optimization problems, which I hope you have, if you haven't, go do optimization problems. Okay, we're gonna have to isolate for h eventually, right? But fine, let's do the volume first. So what is our volume of this thing? Remember, the volume of a prism is always the area of the cross section times how high it is, right? You're literally extending it. So then we know our area. Maybe I will write this. So area of the cross section, they call it the base, and then times height. So the area of the cross section is 3 root 3 over 2 x squared. And then this is times h. So you can see what's going to have to happen. We're going to have to go back to our friend over here, and we're going to have to isolate h. No problemo. Okay, so subtract 3 root 3 x squared from both sides. You can imagine your friends in the older grades and trying to answer this question, and yeah, some of them were not so happy with that question. Okay, so there it is. This is our expression, so we're just going to substitute that in, no problem. And then yes, no, first we need the area of the cross section as well. Okay, so the area of the cross section is right here, and so this is going to be 3 root 3 over 2 x squared, and then we're going to multiply it by this thing. Oh my god, it's all right, it's all right. We're going to come out smarter on the other side, stronger. What doesn't kill us makes us stronger. Okay, so now very careful. Remember how to multiply fractions, top by top, bottom by bottom, okay? So the way that this multiplication is going to work is this is going to be 3. So you're going to have 3,600 root 3 x squared. That's your first term. And then your second term, okay, you need your grade 9 root knowledge, okay? So 3 times is always outside by outside, and then it's inside by inside. So 3 times 3 is 9, that's fine. But then with the root 3's, you can actually do it on the calculator, but what's going to happen is when you have root 3 times root 3, this ends up being root 3 squared. So then the square root and the square falls out, okay? And it's just 3. So you might just want to make a note down there in the bottom section for things to remember, that when you have root a times root a, your answer is just going to be a, okay? So now you're going to have 9 times 3, and this x squared times x squared is going to be x to the power of 4. Okay, now in the bottom we have 12x. Oh God, all right. Right. Okay, so eventually we're gonna need this. Okay, so you're gonna see we're gonna need to separate this out. What's happening? This is 3,600, Miss Walsh, not 360. Okay, so this means that the 12x divides the first term and the second term. So I'm just gonna take a moment and just write them out separately. So that will help us to simplify. So there's this divided by 12x, and now we're going to have 27 x to the 4 divided by 12x. Okay, so now divide out 36 divided by 12. Look at that. That smells good. All right, so this is going to be 300 root 3. And then this is x squared and x. So what's going to happen is that one of them is going to be x, okay? And now this thing is 27 over 12 divided by 3. Ha 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 ha. If you want, you can use a calculator, right? You can do like 27 divided by 12. Remember that ABC button? That's your friend, right? Oh my God, it's 9 over 4. Look at that, amazing. And then if you have 4 x's on the top and 1 on the bottom, that is indeed going to work out. So were amazing. By the way, you do have to just write, even though they give you the answer. I looked in the mark scheme and they said don't award the final point if the given answer is not written. So you do just have to show like, oh my God, look, I clearly showed that. Okay, that was honestly the hardest part of this question, okay? The rest we can totally do. So, and if you want to, you can pause it and try to take the derivative by yourself and all of this stuff, okay? Okay, remember with the sketching, you better have a sharp stop at 16, right? That's a restricted domain. So take a moment, put it in your calculator. Oh my God, it's in my calculator. I was just trying to speed things up. So just go to shift plot and make sure I've shifted it a little bit. Just set it to 0 to 16 to see what's happening. And then there you are. If you're not sure, another idea, you might just want to, by the way, the zoom integer is amazing. So, because I only care about integers. Oh God, 902. Anyway, it's in the negative somewhere, okay? So just have something like this. It's a sketch, it's not a draw, so it doesn't have to be perfect. So we are going to have something like this, and then make a sharp stop, okay? If you want to be super keen, you can find the root. It's at 15.1, so what I drew there is probably about correct, okay? So with the 2 marks, they'll give you 1 for shape, 1 for restricting the domain. Okay, derivative. Try it on your own. Do not be afraid. Okay, so first of all, just whatever, even though there's a root, it's just a constant, okay? So your derivative, you know the derivative of 2x is 2. Derivative of 5x is 5. So this is just going to be 300 root 3 minus, now this 3 is going to drop down. So this is going to be 9 over 4 times 3. And then the power will go down to 27. And so our final derivative is going to be 300 root 3 minus 27 over 4 x squared. Okay, so not a drama. Good. Find the value of x, which maximizes the volume. To be honest with you, it doesn't say hence, okay? If it says hence, you must use the derivative. Set it to 0 and then find out where the root is, okay? But it doesn't say that. It just, they're just happy with you finding. So since I already have this, the fastest way to do this is just to find the extremum. Remember what the variables here, right? This is your x, and then this up here is your v. So then the x that will actually maximize this is going to be, and remember, you can like rewrite the whole number out. Look, this number ends, so there's actually no reason to round it. But if you're really wanting to, then you can also round it, write the rounded value. Hence or otherwise, so it means like use the one before, or you can use the original one. Find the maximum possible volume of the box. It's right there. So this is nice and quick now, hey? But that first section, I know it looks easy when you watch a video, but whoa, whoa, whoa. Whoa, whoa, whoa. For you to get these 7 marks, if you got these 7 marks, you are probably getting a 7 on the exam, maybe 6, but I'm not going to say it. Okay. What's the units here anyway? Centimeters. Okay, so then this is going to be in centimeters. Sometimes they do take a unit penalty off. So let's just be good and put the units on, okay? So that's your maximum volume that you can achieve. Because again, you can make these like, you can make the hexagon thinner, but then draw this way taller, or you can have a huge hexagon, but then not having as tall. There's more than one way to satisfy this constraint. Last one, it's only 1 mark. The box of contains spherical chocolates. Now I'm starting to like this. Okay. Spherical, so if you did have to calculate something, that would be your sphere formula. Manager assumes that they can calculate the exact number of chocolates in each box by dividing the volume of the box by the volume of a single chocolate and then rounding it down to the nearest integer. Explain why he's incorrect. All right, so sometimes they will actually have you do this, right? Where you see how many fit. But here you don't have to. All you have to do is like basically if you're assuming that you're fitting them perfectly, right? And that's not going to happen. So you just have to say something logical, something like when you don't sound like an idiot. So just say something like, I don't know, there's space. So, so we'll have space between chocolates, or that they don't stack perfectly, air in between, just something like this. Okay. Don't think you can now do this, and don't think that you can now do this under pressure. Give it a day and then open it fresh and then see if you can well and truly get it through on your own. Ciao, ciao.